This is the beginning of Unit 1, Video 8, the last video in this Unit 1 series. We're going to talk a little bit about nuclear weapons to wrap out our nuclear energy unit. Whoops. Here we go. This picture here is a picture of a nuclear explosion from a practice bomb. You see a nuclear explosion as a massive explosion. Now, in the last, we were looking at the problems with nuclear power plants, and we saw that there were some serious nuclear accidents at Chernobyl and at the Fukushima power plant recently. And you saw pictures that the tops of the containment devices had been blown off due to chemical explosions. Now, this is proof that there was not a nuclear explosion there, because had there been a nuclear explosion at Fukushima, the destruction would have been about 1 mile radius around the nuclear reactor. 1 mile radius, everything would have been completely vaporized and obliterated. And so, obviously, one problem that is not a problem with nuclear power plants is the threat of nuclear explosion. In order to have a nuclear explosion occur, you have to bring together a critical mass of fissionable material. Okay, and that is a certain amount of the fissionable material needs to come together such that the fission reaction is sustained as a chain reaction. And for uranium-235, the two common fissionable materials used in fission nuclear bombs are uranium-235 and plutonium-239. And you need about 33 pounds of this fuel to come together in one place very quickly at one time. And if that occurs, then there's enough neutrons being given off by that fuel to sustain and what we call out of control nuclear fission reaction. Okay, so we're going to talk a little bit today about how we get this fuel and how you bring the fuel together such that you can cause an uncontrolled chain reaction to occur to give you a nuclear explosion on the magnitude of destructing a 1 mile radius in area. Okay, so first of all, a lot of building and deploying nuclear weapons is a very, very difficult and expensive operation to carry out. The isotopes uranium-235 and 238 behave essentially the same in all chemical reactions, so this just to separate them is extremely difficult and relies on advanced technology that's not readily available to a lot of the developing nations in the world. Okay, so first of all, you have to get the uranium, and I mentioned before that the uranium-235 is the so sorry. Uranium-235 is the fissionable material, and plutonium-239, and you get plutonium-239 from uranium-238. Okay, so in either case, you mine mostly the uranium-238, you separate out the uranium-235, or from the uranium-238 you manufacture plutonium-239 from a neutron capture type of nuclear reaction.